Welcome to this demonstration of Schneider Electric's Asset Link solution. This is the second part of a video showing how to generate a pattern in Asset Link in order to integrate user-defined function blocks from Control Expert into Aveva System Platform. We will briefly go through some examples that explain how to update an existing Asset Link pattern and how to create patterns when using a structure variable that contains structures within it, as well as linking multiple structures from a function block. Please bear in mind that this is a basic demonstration, not intended to replace any formal training. The user might also need to adapt the configuration shown to the actual project requirements. We will start where we left the first part of the demonstration, in which we already generated a pattern file for a derived function block designed to increment a counter every time one of the inputs transitions from false to true, also allowing to reset the counter or change the limit at which the counter will reset. What we would like to show now is what happens if you change the design of the function block from Control Expert and how to update the pattern file in Aveva System Platform. To illustrate this, let's go back to Control Expert and modify the design of the function block. First, we will add two more elements in the existing counter DDT that we have created before. One is an integer called multiplier, and the other one is a real variable called result. We need to disconnect from the simulator in order to build this change. I will now add an input variable to be associated to the multiplier, which will be a value supplied by the operator. We also need to add an output variable for the result, which is a real variable. And now what we will proceed to do is to modify our function block by adding a multiplication function block within our section. I first convert these two factors into real numbers, so the product will be a real variable to be linked to the result. Let's build these changes again. Lastly, I just need to add the newly created variables on the function blocks. Build the program. Export the variables, replacing the same file we had before, connect to the simulator, and transfer the program. Now let's go to Aveva System Platform. The change can be done very quickly by modifying the template of our counter asset and its graphical template. Let's first open the graphics. We just need to copy and paste the objects we had for the preset value. We change our text box as needed. The variable we will use to write the multiplier has to be updated, so I will remove the value restrictions. Lastly, to display the result, I will simply copy and paste the first line I had for the present value. I will update the text to be displayed as product result, and I changed the attribute to result, as you can see in this example. That's all for now. We can save and close. In the counter function block template, you will see that the graphics have already been updated. We just need to add the two new attributes with their corresponding placeholder I/O address. Let's first add the multiplier integer attribute. And now let's add the result attribute, which is of float type, with its corresponding placeholder address. We're now finished here. Save and close, and you will see this interesting warning message letting you know that the changes we have just applied will be pushed to the derived instances, which is exactly what we want to do. Click on OK to save to accept the updates. Now you will notice that the instances have a yellow and black square to remind us that changes have been applied. If you inspect any of these instances, you will notice that the new attributes were added with the placeholder address. Now we will go and update the pattern file so AssetLink can complete the correct I/O addresses for us. Let's open the AssetLink template again and go to the Patterns tab. This time we click on Update Pattern, which is the button to the right. We will use the CTR tag name again, and we click on the Update Pattern button. We can increase the version number if we wish to, and I will select Create New Pattern to avoid duplicating the rules in the existing pattern file. As a result, you should find the two new attributes in the Rules section for the multiplier and the result attributes. Now we save the changes and we can replace the existing pattern file. Finally, let's go to the Generation tab and browse the control project. We just need to select all the candidates, generate the objects, and as a result, the three assets are updated. Now simply deploy the updated assets, as well as the View app. Now we can open the operator interface and confirm that all the changes have been applied. And we can now observe that in the operator interface, we will have the three instances updated for each one of our objects or templates. We can log into the system as well in order to change or write values to the controller. In this case, we will change the value of the multiplier, and immediately we get as a result the multiplication between present value and the multiplier. And we can do this as well in the other two instances that have been modified through the method we have illustrated. So in the test we have done so far, we only used one structure type variable. What we would like to know is how to create a pattern when we have more than one structured exchange between the controller and AVIVA System Platform. So let's start by adding a new structure, which we will call config DDT of structure type. Then we will add two real variables, which we will simulate as a setting for minimum and maximum temperature. Just as an example, there's no special reason why I'm talking about temperatures. And then we can build the application, and changes can be updated online on the simulator. Now let's create a new function block called mixer FB. we will add two input-output variables to be exchanged with the HMI. And following best practices for the general purpose library, I will name the function block pins with the name of the function block, plus underscore, and CFG to represent configuration variables. The type we will use is of config DDT, which we just created. The second input-output pin will also start the mixer FB, followed by ST for status word. Then the data type will be counter DDT, which we have used before. I will not add any logic, as we just want to illustrate the process of linking the variables with asset link. We can now build our changes, updating the program in the simulator. We will now create a new FBD type section called line 1, for example. And here we can add our mixer function block. I personally prefer using the function input assistant because you can give the instance a proper name before adding the function block into your logic. Following best practices, you would start with the equipment name, the underscore, and the name for the function block. At least that's how it's typically done when using the GPL, so I recommend following that convention to be accustomed to the way things are done in the general purpose library. Now we can create the new variables connected to this function block. Again, for most function blocks in the GPL, the variable names start with the equipment name, followed by the name of the input pin. So we will call our first variable as tank1 underscore mixer FB underscore CFG. The second one would be tank1 underscore mixer FB underscore ST. Once you get used to the syntax for naming variables, it's easy to follow. Please do not forget to enable the HMI variable attribute on anything you will exchange with the HMI. As you can see here, when creating variables, this attribute is disabled by default. So go ahead and turn on the HMI variable. And with that, we can build the changes and export the variables, replacing the XSY file. Lastly, I will just change a few variables to have something different than 0 show up in the HMI. In the animation table, I will type in some values for some of the variables, and then we will confirm what we can see in Aveva System Platform. Now, in Aveva System Platform, based on the user-defined template, I will create a new derived template, and I will just add a few attributes for this example. Just as we did before, let's add preset v as an integer. And as before, we will need to add a placeholder IO address, which in this case will be ... exclamation mark tank1 underscore mixer FB underscore st dot preset v. Let's add a second attribute as PV, also an integer, and the necessary placeholder address. Now, what we need to do differently is to add an attribute associated to the second structure. For example, temp_min, which is a real variable, and the placeholder address must reference the CFG structure. So the address becomes ..exclamation mark tank1 underscore mixer FB underscore CFG dot tempmin. We will not add any graphics on this template, we just need to save and close. We now create a new instance of our mixer template, and we will call it tank1, which has to be the same equipment name that we are using in the function block instance in Control Expert. Now we open the Asset Link object. We navigate to the Patterns tab, and we select the Create Pattern button. The tag name we need to use is tank1. Then you click on the Generate Pattern button, and you will see a pop-up window which will let you know that two variables, which are actually structures, were detected and can be used to generate a creation rule. So here's the trick. Press the Shift key and select both variables with the mouse. If you forget to select both of them, only one of the structures is going to be considered when generating the pattern file. Now click OK, and you will see that an object will be created when both of these structures are detected in the XSY file and the variable starts with the same tag name. Then, in each rule, you will see what attributes will be included in the pattern file to create an asset. So we can now save the pattern file. We can close out. And then go to the Generation tab, browse the control project, select the tank1 object, so click on Generate Objects, and you should see a successful update. Now you can save and close. If you inspect the tank1 attributes, they now have the complete I/O address. Now move the tank1 asset into our area and deploy. If you would like to check that the variables are updated in the Modicon communication server, you will see the three new attributes for tank1 are displayed with the values that we had set before. Now let's do one last test to see how we can create a pattern when our function block uses a variable, which is a structure containing structures inside. So let's create one more DDT type, which we will call starter DDT. This DDT type will contain two variables, counter as a counter DDT type variable, and config, a config DDT variable. We can now build the changes online. We create a starter function block, starter FB, which will have a single input-output variable, naturally called starter FB underscore ST of the starter DDT type. Now we can build our changes. We will now add an instance of our newly created function block, and we will call it tank2. Following convention, the variable name is called tank2 underscore starter FB underscore ST as a status word. We can now go and enable the HMI variable feature, build the changes, and export the variables. Let's put in some values in an animation table, and I will take this opportunity to point out that in the placeholder address in the AVIVA System Platform derived template that we need to create for tank2, we will need this complete path for each attribute. In other words, preset V will have a placeholder address containing tank2 underscore starter FB underscore ST dot counter dot preset V. The same applies for the present value PV and our temp min attribute, which must include tank2 underscore starter FB underscore ST dot config dot temp min. We repeat the procedure by creating a new derived template and add attributes. We now add each attribute with a placeholder address considering the complete path to the element in the DDT structure we are using. As before, start with ... exclamation mark and then continue with the DDT name tank2 underscore starter FB underscore ST dot counter. In the case of the PV, present value attribute, the IO address similarly is coming from a DDT structure .counter. It will be in the case of the parameter temp min, which is a real number, float type. In the IO address, instead of .counter, we need to use the DDT type .config. We can save and close. Now we create an instance of the starter FB template and name it tank2. We can then go to the asset link object to create a new pattern. This time the tag name will start with tank2. And now we have our creation rule when the starter underscore ST structure is detected, creating these three attributes. Save the new pattern file. Now go to the Generation tab, browse the project, select tank2, update the tank2 object. Now move tank2 into our area and deploy. To confirm we are reading values, right-click on the tank2 asset, select View in Object Viewer, and now select the three attributes we want, adding them to the watch window. This concludes our demonstration. Thank you very much for your attention, and I hope you will find this video useful for getting started with EcoStruxure Asset Link. Please do not hesitate to look for additional resources and videos for Asset Link, which are available in the Exchange platform.